Welcome, my name is Oliver Schneider. I'm lecturer from the Institute of Virtual Design Construction from the University of Applied Science, Northwest Switzerland. It's a great pleasure to give you in this web tutorial an insight of the GeoBIM web application, an application which was developed during an Innosuisse research project during the last 2 years. The web application is one out of several results which was developed in the consortium. To get a better overview what we developed over the last 2 years in the innovation project, you can check these two links. On one hand side, it's the landing page, which you see on the left side from chgeol.org, geol_BIM. There you find all connecting links and also two documents which were published recently, and also our final report, which is also published in German and in English. The other two reports from the initial work are only available in German. Then there's also all the code and the web application, what I will show you in that tutorial. You can find on the public gitlab.com chgeol, and there you find several projects where you can also find the codes which can be used for there. Good, so what can you do and what is the main purpose of the web application? As the name GeoBIM already mentioned, it's related to transfer the geological information to the digital building models and to bring them to the coordination models and bring geological information to the IFC. In the web tutorial, you will see also later on, we have different kind of geological information, and these three different kinds of them are divided either in what is mentioned here on the top, GF, geologic features, which is in mainly 3D surrounded models. And then we have an adapter programmed and available, which is related for boreholes. And then also, last but not least, we also have developed an adapter which you can transfer voxel models to the IFC. And how we are doing that we transfer geological information to IFC. For that, you have to mention you have to prepare your data, and that's what I'm going to show you later on. But just to give you a quick overview, so these three different adapters, as we call them, so for borehole, voxel, and geologic feature, expecting different kinds of information. So in general, we're looking at the data is prepared and collected in Excel files, and that related type of data in there is kind of a collection of different boreholes or voxel information. The project data, metadata, and then for sure for the case of borehole and voxel, there is also the geologic data in the Excel, or there's one exception for voxel. We also use then the options that you can link in the Excel to a CSV file, which the main purpose on that is the performance and also the data amount of voxel. It's rather larger than it's related to boreholes. Good. Then for geologic feature, there we're looking also in surfaces and also volumes, which we can transfer there. Additionally to the Excel file, you also have to prepare, or you have to export from your geologic software or expert software the information geometry, either in one of these geometry types. There's DXF, OBJ, STL, and TS supported, and this is your preparation work. There is also on the GitLab links available where you can find the templates, and there is also a tutorial available, which I'm going now to show you in the web app, which you can do on your own, the tutorial, and that's related to all these three adapters, and it's a tutorial from Switzerland. So before we now start to go to the web application, I would recommend you to go to the gitlab.com account from CHGeol and download the demo project, the tutorial, that you now have all the data to do on your own, all the steps what I will be showing you briefly in a second. Good, you can find on the CHGeol several projects. If you go to the first one, the server UI, you will find there also the folder of demo project, and there in the demo project you can find there for all the three different adapters, as I mentioned before in the graphics, borehole, geologic feature, and voxel, either Excel sheets, or also in the case of the geologic feature, you also find the geometry examples. So you can download these elements either direct clicking on the data, or for sure you can also download the entire source code and the direct directory of that. Good. Afterwards, when you have downloaded the adapter, then it's time, so you can go to the web application you can access within the URL, or either when you now see this tutorial you are already on there, but the URL for those who is coming first to the web tutorial and now you want to find the application, it's on geobim.fhnw.ch, and there you can start with the login page. For those who don't have a login, please contact the contact details over our landing page, us, so we can generate you an access, and then you can also try the code directly through the web application which we are hosting. Good. I mean, the email the user, each of you will get then also personalized password. When you enter the web application, you can find here it's kind of the user interface. It's right now all in German, so there is no localization implemented right now. But here you can find some basic application about the user settings and about the about dialog, and then the main topic in here, it's the possibility to define transformation jobs. That's also the only button you can select here. When you press the button here, you can start to define a new transfer job. So I will call that demo project, and I'm going to start with the borehole data to IFC. When I've generated the job, I directly are in the mask where I now can upload the input data to the job. And that's what I showed you before. We have three different kinds of input data. One is borehole, the voxel, and the geologic features. And now I'm going to start first with the borehole data. I will add in here bore profile, and then you will see I will have a new entry here that I have to load now here the Excel files of the borehole. With the upload button, I'm requested to choose the data, and now just maybe have a quick input to show you. Before, when you download the demo project, you have this three subfolder, and on the borehole to IFC subfolder, there is the one Excel file you can use. On the geologic feature to IFC, there is one Excel file and three geometry examples. And on the voxel to IFC file, there's one Excel file and the CSV file. Maybe before I load that, let's have a quick look to the Excel files. In our reports and in our documents, the Excel files are well described, and this is also linked to our reference and transfer model, which is developed and explained in our report. Each of these Excel files are having the same structures, and the borehole is the one which has the most information. So this will take a little bit longer, and then afterwards you will see from geologic feature and voxel The first two are identically, so project data metadata and survey points, and then the other ones we have a slightly different choose of the information. Let's have first part explanation on the register project data metadata. It should be somehow self-explaining. On one side, you will see also always here column A, which is defined what are the element type in here. There is also the link directly how we write the IFC to which IFC entity, and then there is a short description, and the value is on the column C. There is maybe some speciality in here. What we implemented as georeferencing is for geologic data a key issue. So we're supporting in here, as the reports explained, the low georef classification, and the recommendation is here to 3040 or even the 50 class. There is also a possibility to have direct EPSG code accessed in here. So you see here, as we are having a Swiss innovation project, we're using here as an example the code for Swiss reference system, but it's possible also to change here to the EPS code from your local country. Then there's one specialty, as often we have the geologic data representing in absolute coordinate systems, so in georeference coordinate systems available, or geodetic system, and then we have our project or the BIM project in local coordinate system. For that application, we implemented the possibility to use translate coordinates. So for example, I have that now in the demo data on false, but if I put this value to true, all the data, the absolute coordinates data of the borehole, will be subtracted by the project origin coordinates, and that will bring us then from move our absolute coordinate system to a local system. So quite a nice feature, also to use maybe for auto conversion rules when you want to combine, for example, digital height models to local reference. That's a possibility. Good. Then there is also the possibility to choose which IFC version. That's especially important for some of the features on geotechnical stratum, which are available only since 4.3. And for that application, we have different mappings implemented to IFC4 or to IFC 4.3. So the mappings are also explained in the reports, and that you can also have an explanation. Then there is also, in particular, only a setting which is used for the borehole. It's related to the representation, for the geometrical representation. There are two different possibilities, either sectionite solid horizontal or extruded area solid horizontal. So here it's quite easy and simple. You just change the value, and then the application is changing the way how their data is prepared. Good. The next block is about project metadata. Here you have possibility to give the purpose, the phase. You can give some versions and also important topic, who is the delivery party in the organization of that data. Then there is also some geologic model information possibility. So the type you can define, then there is different dates possible, the date of the model and the date of the processing of the data from the geologic site. And then also you can add here the value of customer and consultant data. Good, so let's switch to the next tab, which is register, which is the survey points. Survey points are an important topic to, especially in coordination models, that having a quick check that all the sub-models in IFC are overlaid correct and using the same reference system. Here we implemented a reference paper or reference study from the use case of building smart Switzerland, and we defining or simply adding in the IFC directly the path point or the local coordinates with like pyramids for the placement, and for the height information we invert the pyramids to the top and having then a geometry element and also the entity written what kind of information is that. So quite an easy possibility to check if all my data in the coordinate system using the same reference system. Good, and then we come to the important or the interesting topic. So that's the possibility where you can define all your boreholes. In that example, you see a list from that project from Swiss Topo. We have different kind of borehole ID, a name. We have the coordinate system, the type of borehole, inclination type, then the dates of the drilling, and then also further information about purpose and start point and the data custody. Good. Then the next topic is about the geometry. In that case, we only have vertical boreholes, but it's also possible if you have a borehole which is defined on several kinks and on several things, then you have just from the same borehole ID not only a start point and an end point of the coordinates with a different height offset, then you can really have your absolute coordinate system moving along the pipes. Then we come into the register which the most of the information is putting in, so the interval geologic feature. Here it's now each element defined, and here you also have then to choose from where to where. If I'm defining here geologic feature object type, the base type differentiation between unit and structure, and then also the perspective. Either is my geologic feature on the perspective of geology, geotechnical, or hydrogeology, and then we also have here the possibility to choose from subtype list which is defined and which is also possible to add here and customize. The classifier indicates then a relevant indication of the class, and then we have here the defined property sets of the geologic feature, which we here defined on one hand side a layer description, and beside here it's the property. You can either use the default value which we have evaluated in our research project, but also here you are free and open to change the values to your restriction in your project. Good, and last but not least, we also have here the interval drilling completion. Here we can bring the information together and also give adding value about the completion type of the borehole, and last but not least also the diameter of the borehole. Good, so what is now happening if we choose now the data? So that's now I have just chosen the Excel file to the web application. And now when I've uploaded the data, you see that the process, the IFC, is showing up, and if I press that data, the IFC conversion code is now done. And here you sometimes have to refresh the browser, and then you can see that now you can download the IFC data, the result, and also the log data directly in your download. And then once you check that data, you download the data, and then you can use the software or the BIM viewer you want, and you can analyze the data which you just downloaded. Good. So now I have opened the result which we just generated with the web application in a free BIM Collab Zoom viewer, And now you can see that I have now here the pillows, which are showing here on one hand side the geological information, and here you see also now the property set CHGL, where you now find also the value which was standing before directly in the IFC file. And now we have on one hand side the layer description and the USCS code, and that varies now where you are. Furthermore, you can also see that we have here now 3 additional the survey points, and here the survey points are showing also the P set, what we were showing before, having the easting northing height information, the naming, and then also a local information system. Good. So let's go back to the web application, and now have a look how we can transform the next geologic information. Good. So for that case, I'm going now to do that for voxel to IFC and generate the job. Same thing here. Add the voxel layer. Here I can upload the data, and now what you can see here, when I chosen the voxel, and there's a slightly difference showing here, that now I have, beside on the Excel, I also mentioned to upload the voxel geometries, and in that case the voxel geometry are added in the CSV file. So I furthermore upload here the relevant CSV file, and before I transfer the data, I give you a quick look how the Excel is looking like. And there's now you already know from the borehole and the principle, the structure of the data. So I have to open the Excel, and here you can see also that we have the first two register. So we see the project data and the survey points are identically. And then we also have a register for the voxel geologic feature. And here we link, we can define an ID, and then we link automatically the file name where the geometry stands for. And then here we have the voxel definition, and with that information of the double point center, we put the column name, which is linked listed also in the CSV file. And the same also, that's the kind of the center point of each voxel. And then we also have here the dimension of each X, Y, and Z. So this must be the same value, so it can be different, which is normally also the case. And the same thing now in that example, we have here a value for uncertainty, lithostratigraphy, and standard deviation for maximum permeability. And that's also then the values which are listed here in the CSV. And once again, why CSV? That's mainly just a performance topic, as we have here often cases to have millions of voxel which must be transformed from geologic to IFC. But here you see the same structure and the separator in here. Good. So let's come back here and generate the IFC file, and also doing here the same thing so this takes a little bit longer as we have some power, some few more voxels in that example, but yeah, it's after 10 to 15 seconds done. And once again, refresh helps, and there you can also then download the IFC file. So in that example, the IFC which we just generated is 25 mega. Just mentioned that there's maybe some of the viewers, I mean, it's open to view that in different viewers, but some of the viewers need also some performance topics to visualize that. But BIM Collab or BIM Vision or also Solibri, which we tested often, are fine with that. But also we had projects where we rather had bigger amounts of data, and then there is also the viewing component can be a little bit longer. Good. So now we have here our voxel model. Still in gray. I can also use now here BIM Collab my predefined color principles, and after that I have now this using the same color principle which I was also defined before from the wobble. And if I now pick on each of the voxel, you can also see now here that the voxels have now the information in here, and also the information which was defined, so uncertainty value, lithostratigraphy, and the standard deviation for maximum permeability. Good. So that was how voxel can be transferred. And then I will come to the last adapter, the adapter for geological features. And so let's do that again. To IFC. Here I'm using now the last button in the web application, and when I upload here the geologic feature class, I can use now in the demo project in the folder geologic feature the Excel, and here now I will explain that afterwards. Well, the upload for one of these Excel will take them a little bit a while, but here we directly have the 3 external geometry files. And I'm already requested once the Excel is written that I upload that recent relevant data here. Good. So first we have one of the structure to upload Felderschotter clip. Then we have an OBJ, also a structure element Moraine, which I upload here, and then last but not least, we also have a unit, so an entire volume we're going to upload, and in the format of TS. So this will take then also, it's a little bit longer to upload because it's about 9 megabyte data. So mainly these data are meshes, triangular derivative networks, which you can upload in here. And now also we have a quick look to the data, how it looked like. So geologic feature, the Excels is defined similar than the other ones. The first 2 register are identically. So we have the folder of project metadata and survey points, and then on geologic feature we have here the findings, the object type defined. Here we also can choose what type of RGB values for representing the color in IFCs, and then we have the adapted list of information we want to write to PSET solid stratum capacity. Good. So I will now also run transfer the geologic feature information to IFC, and that's also, it's not that long once the data is uploaded. After refresh, you can also see that you can download also that result, and here we can do then the same thing. Open the data within the preferred BIM viewer you want, and you can analyze then the result in IFC. And also, beside on having the geometry in IFC, you also have then the information, geological information ready in IFC. Good. So in between, I have now modeled my IFC of geologic feature in BIM Collab. Here you can see now the 3 triangular irregular networks which are defined. And now I can also switch off the unit felder shutter, so you can see a bit better that we have now the 2 structure on one hand side, the moraine, and on the other side the felder with the relevant information about which we just generated within the web application. Good. So that's now why BIM. One of the major benefits out of BIM, it's also that we can combine geologic information also with other combined information. And for that example, in that case, we put the alternate building models combining here. So that's this data which is open and access for everybody in IFC implemented. And in that particular case, we also have models available of the sewage system and also on the freshwater system of that region. And here you can only get an impact a little bit, and that we now have all the sewage and freshwater modeled. Furthermore, in that case, we can also use the electricity models which are generated. And now you can imagine when we have a complete model of buildings and geologic feature models, we can now also add our borehole data of that element, and then also the voxel. Alternative, we also can switch on a digital building model, which is also open to access in that case. And now, when we showing you when we generating cross section, you can also see here the possibility that you now can correlate the information. So, for example, one thing, so I know now which utility layer is in which geologic layer in there, and also you directly see the voxels are linked within our data. And for sure, we can add here as well several layer, and then we can also see our borehole information. Good. So that was a quick tutorial about the web application. So feel free to really choose the web application, choose the templates for your own purposes. So the templates you can generate, and you can add your specific project data. And if you have questions, we are more than welcome to trying to help you. And we will also be interested for sure to get your comments and feedback, and maybe also some recommendation what in the future could be done and could be developed in that particular. So thanks a lot for your attention, and it was a pleasure, and enjoy your day.